So now that we have the law of sines, we can solve a lot of triangles that before, well, they were still possible before, but now it should be a little bit easier. We don't have to drop the altitude every single time. So I would recommend drawing a diagram each time. It's not required, but it's not a bad idea. So we've got T, it's 30 degrees. R is 100 degrees. And let's see, that must mean that this is S up here, so side S equals 15. This is side R, and this is side T. And we need to find side R, side T, and angle S to finish this problem. We're going to solve the triangle by finding all the missing sides and angles. Okay? So angle S should be the easiest. Angle S is equal to, well, these guys add up to 130, so this must be 50 because all three angles have to add to 180. So that was the easy part, but now we're going to go ahead and find the sides. We do have one angle side pair. Notice that we know angle S and side S. So we should put angle S and side S in our equation. So the sine of S, or 50 degrees, over side S, or 15 units. And we know that this is going to be equal to the sine of some other angle, let's say R, so that's 100 degrees, and then divided by side R, which is little r. So there's an equation that we can use to figure out what R is. Cross multiplying, we're going to end up with R equals 15 sine of 100 over sine of 50 degrees. I'm going to skip the algebra steps because you guys already know algebra. I'm just going to jump straight to the part where we type it in the calculator. So again, make sure your calculator's in degrees mode because 150 are being measured in degrees. So you do 15 times the sine of 100 degrees, close the parenthesis, and divide that by the sine of 50 degrees. And we get, according to my calculator, about 19.3. So R is approximately 19.3. So I'll fill it in over here as well. The only thing that's left now is side T. So I would just go back to the same equation we used before. What's a good color? I like purple. So I would still do sine of 50 degrees over 15. But this time, instead of using the 100 degrees, I'm going to use the 30 degrees. So that would be sine of 30 degrees. And 30 is angle T. So that means we're going to put side T down here. And that's going to look shockingly similar to the last problem. The T times the, 15 times the sine of 30 degrees, and divide that by the sine of 50 degrees, 50. So notice that everything stays exactly the same except I changed my 100 to a 30. So yeah, we type that into the calculator and we get an answer, which is 9.8 or so, 9.8. T equals 9.8. T equals 9.8. Now, if everything's drawn to scale, then these should look relatively accurate. And the smallest side is opposite the smallest angle, and the largest side is opposite the largest angle, etc., etc. So every time we have two angles in a side, law of sines is the way to go. Notice that on this particular problem, the given information was an angle, side, angle situation. What about this next one? We'll start off the same way. We've got angle L is 29 degrees, so I'll put an L there. Angle M is 112 degrees, so I'll make that obtuse-ish angle M. And then the other corner vertex is N, So I'll put the n right there. Triangle element, and side L is going to be equal to 22. Side N and side M are unknown. Well, we've got two angles, so really every time you have two angles, you automatically have the third angle, right? We just have to subtract from 180. So 180 minus 112 minus 29 is 39 degrees. So if you add 29 plus 39 plus 112, you should get 180 degrees. So that's the measure of angle N. That's equal to 39 degrees. And once again, we've got an angle side pair. This time the angle side pair is L. We have 29 degrees for angle L and 22 units for side L. So that's what we want to definitely include in our equation. So we'll do the sine of L. L is 29 degrees, divided by side L, which is 22 units long. And if we want to solve for, I don't know, we'll start with M. Then angle M is 112 degrees. And side M is what we don't know. So multiply both sides by M, multiply both sides by 22, and divide both sides by sine of 29 degrees. And it's time for the calculator. And it tells us, drum roll please, 42.1 or so. 42.1 is the length of M. All right. Now, I would expect N to be a little bit bigger than 22 because it's opposite 39 degrees instead of 29 degrees. So keep that in mind. Something like, I don't know, maybe 25 or something. I'm just guessing. So start this other one the same way, the sine of 29 degrees over 22. That's how we started the last one. But this time, instead of using 112, I'm going to use 39. Sine of 39 degrees over side n. So solving for n, we multiply by n, we multiply by 22, and we divide by sine of 29. Now you can just go back into your calculator and change all of your 112s to 39s. And that can save a bit of time. Use the calculator to do things efficiently. And we get, for this one, we get approximately 28.6. Okay, so it is bigger than 22. So I am happy. So our final answers would be n equals approximately 28.6. And we really should get in the habit of writing out our answers in a nice, neat way so that everyone can read them. So m is approximately equal to 42.1. So for each one of these, we've got ourselves an answer of the newly known parts of the triangles.